Hello, this is Mohit from IIT Madras, and thank you for visiting our poster session in WACV 2022. Now we all know that a regular DSLR only captures a 2D projection of the real world, losing the depth information. Opposed to this, a light field camera captures a 4D projection of the real world, allowing for several applications such as post-capture refocusing and aperture control. But like any other optical system, the quality of a light field quickly degrades in extreme low light conditions such as nighttime. We therefore propose a new deep learning based solution to restore light fields captured in extreme low light conditions as seen on the screen. Now, existing low light methods such as see in the dark are inappropriate because they do not leverage the multi-view perspective of a light field. And methods such as L3FNet have a humongous time memory complexity, which is prohibitive of a real-world application. We thus develop a solution that is quite fast with much lower memory footprint. Now our architecture is divided into three stages. In stage 1, all the light field views are depthwise concatenated to get a global activation. This global activation is very crucial in preserving the epipolar geometry across the views. In stage 2, convolutional weights are estimated for the non-peripheral views depending on their angular indices denoted by SNT in the figure, and a view-specific output is consequently obtained. The global activation of stage 1 and the view-specific output of stage 2 with all the neighboring SAIs are then passed through a RNN-inspired feed-forward network to restore the views. A unique characteristic of our design responsible for fast and lightweight restoration is that each forward pass can restore 9 views. Thus, opposed to existing methods, it requires only n square divided by 9 forward passes to restore all the n square light field views. Now for stage 3 of our network, instead of choosing a regular CNN, we chose a RNN-inspired CNN because traditionally RNNs have been considered more suitable for sequence handling, which in our case is a sequence of LF views. Please refer the main paper to know how to convert a higher order RNNs into a feed-forward CNN. Overall, our method not only achieves a higher PSNR with higher SSIM in restoring low light LF views, but more importantly, it has a much fewer model parameters, allowing smaller model size, much lower number of floating point operations, and runs relatively much faster on a CPU and a hardware accelerator like GPUs, allowing a real-world application. One final advantage with our network is that even if it was trained for a 5x5 LF views, it can still decently restore a light field with a 9x9 angular resolution. This is not possible with existing methods such as ResLF, which learns a separate set of weights for each view during training, and L3FNet, which cannot restore the peripheral light field views. Thank you.